Everyone, today we're going to be looking at applications of equations, so what you all know as worded problems, right? Same thing, just differently worded, right? Now, when it comes to worded problems, there are a couple of things to kind of keep in mind, right? We want to try and make our working out as clear as possible, and we really want to define a pronumeral that's going to stand for any unknowns that we might have, okay? So when we find a worded problem, we're going to work through picking out really key bits of information, right? But one of those things we have to do kind of straight off the bat is to define a pronumeral of some kind, right? So let's say we're dealing with apples, for example. You'd say something along the lines of let X be number of apples, right? And that just helps you kind of frame your working out from then on. Then we're going to collect any other key information we have and write an equation. Yeah, I feel like that at this point in time it's kind of pretty obvious is that we are going to write an equation of some kind. But from there, we're going to solve that equation algebraically. That's really, really important, using those inverse operations, right? Sometimes it's going to be really obvious what the answer is, but you are now at a point where you are used to communicating mathematically that we expect you to be able to communicate mathematically. Okay. Now, once you've kind of solved your problem, you're going to make sure you answer. Whoop, I keep picking black for that, which is not a good idea. But you are going to ensure that you actually answer the question, right? But when I say answer the question, I mean using words. Yeah. I'm so sorry, I keep clicking the highlighter there. But you are going to use words. Yeah. So for example, you might have one apple costs $4. Yeah, which is ridiculous now that I think about it. But you might end up with one apple costing $4. It might be a super mega organic, specially grown apple, right? But you would use your words and you would use the correct units. So see how here I've used dollars because the question may have asked me how much one apple costs, right? And then the other thing to keep in mind, which I kind of haven't really with that example there, is to make sure that your answer is actually reasonable. Yeah, I really need to pick better colours for this, but we're going to make sure our answer is reasonable. And what I mean by that is things like time has to be positive, right? You can't have negative time. Yeah. Things like if we're talking about the temperature in Australia, you can't have 130 degrees, right? So consider whether or not your answer is actually reasonable, all right? Now, when it comes to being able to write a worded equation, we first need to kind of revise what some of these keywords mean and how we might write them out, yeah? Now, if I've got something like the sum, okay, questions might ask for things like the total, right? Or combined. Those are some keywords that questions might give you. And we know that sum is adding. Okay, so if we're looking for the sum of x and 3, that would be down here. Okay. Now, the cost of 2 apples, if they cost X dollars each, well, if I've got 2 lots of X, that's going to be 2 times X. Okay. The cost of X oranges, if they're costing $1.50 each, once again, same sort of idea, even though the oranges are now X, you've still got 1.5 times X. You've got 1.5 lots of X. All right. Triple the value of X. If we are tripling something, we are multiplying by 3, which in this case means we've got 3X. And then if we've got 1 more than X, that means we're adding 1 on. Okay, so there's sort of the keywords you want to look out for. If you're confident with worded problems, feel free to pause here, but I'm going to go through it as well. Now, this question here, we're purchasing 3 cans of soft drink and a $3 carton of milk, and that costs the same as purchasing 2 cans of soft drink and a $6.40 bottle of juice. Now, the first thing we need to do is identify our unknown, and that's usually looking for what the question is actually asking. And it's asking for the cost of 1 soft drink can, right? So we want to figure out how much 1 soft drink can costs. And I'm going to say, in this case, defining my variable, I'm going to say let X be the cost of one soft drink can, right? And that way we've kind of defined that variable. All right. Now we've got to figure out how to actually make our equation here. I'm going to focus on that first side. So 3 cans of soft drink is 3x and a $3 carton of milk. Okay. Now, if I wanted to write this out, I've got 3 times x, right? So I've got 3 cans of soft drink, and then that $3 carton of milk is always going to be $3. Okay, so that's my left-hand side of the equation. Now, if I look at the right-hand side, I've got 2 cans of soft drink and a $6.40 bottle of juice. So that bottle of juice is always going to be $6.40. So that means I've got 2x plus 6.40. Right, now it's a matter of moving stuff around like I usually would, okay? Now we're just solving this now that we're down to this point here. We're solving this like we would any other problem. So I'm going to subtract 2x from both sides, leaving me with x plus 3 is equal to $6.40. And then I'm going to subtract 3 from both sides, leaving me with x is equal to 3.40, okay? Then our last step, we're just going to write that out. So the cost of one soft drink can is $3.40. Okay, so make sure that you actually write out your response using words. Now feel free to have a go at this one by yourself, but once again, I am going to go through it. Now here we've got a plumber who is charging a $70 call out fee. Okay, now a call out fee is something that you pay regardless of how long they work. So this is, in algebraic terms, a constant, right? So I'm paying $70 regardless of how many hours this guy works. Then on top of that, I'm paying $50 per hour, right? So because I want to figure out how long this guy worked for, if I've been charged a certain amount, I'm going to let H be the number of hours, right? Now, the letter itself isn't important unless it's been specified, okay? But I'm going to let H be the number of hours. Right. So from that $70 call-out fee and $50 per hour, I currently have 70 plus 50H on that left-hand side, okay? The second bit of information we're given is that I was charged $420, okay? So that means I've got 70 plus 50H is equal to 420, all right? Now it's a matter of solving as per usual. I'm going to start by subtracting 70 from both sides, leaving me with 50H is equal to 350, and then dividing both sides by 50. Okay, so I'm at H equals 7. So the plumber worked for 7 hours. Okay, don't forget that you do have to write a worded answer with your worded problem. Once again, pause the video if you're confident, but this is another problem we love to throw at you, especially at a year 8 level, okay? Here I've got 3 consecutive numbers, okay? Now consecutive means in a row. Oh my goodness. Okay, consecutive means in a row. So that means numbers like 1, 2, 3, or 47, 48, 49. Right, 3 consecutive numbers all in a row. Now this is a bit trickier because we're trying to figure out what those 3 numbers that add up to 123 are. So I'm going to let X be the first number. Okay, now you don't have to do it this way exactly. However, I find this to be the easiest way. And so if you wanted X to be the last number, you would just have to alter accordingly. Now, I'm going to let X be the first number, and I know that my total adds up to 123. If X is my first number, that means that X plus 1 is my second number, okay? And then after that, X plus 2 would be my third number, okay? So this is my first, X plus 1 is my second, and then X plus 2 is my third. Okay. Now it's a matter of simplifying and solving. So I've got 3x plus 3. I'm going to subtract 3 from both sides, leaving me with 120 equal to 3x, and then I'll be dividing by 3. Okay. This means that my first number is 40, and then it's the two numbers after that. So the three numbers would be 40, 41, and 42. And if you add them all together, you should get 123. Now, this is my last example for you today. I do think this is the hardest example out of the lot, so feel free if you'd like to give this one a go. Now, we have 4 ladies here. Each of them have a relationship between their ages, right? We've got Amy is 2 years older than Betty, so Betty is going to be Amy plus 2, okay? Caroline is double Betty's age and Darlene is triple Amy's age. So everyone can be written in relation to Amy, all right? So what I'm going to do in this case is say let X, or it doesn't really matter what you pick, but let X be Amy's age, okay? So we have Amy, who is just X years old. We have Betty, who is X plus 2, okay, because we're writing this in relation to Amy. Then we've got Caroline. Now, Caroline is double Betty's age, all right? So she's double Betty's age. So I'm going to double X plus 2, okay, using brackets like we have before. Then lastly, we've got Darlene, who is triple Amy's age. Okay, so these are currently the ages we are working with. Now I'm going to add each of these together, and we've got a combined age of 55. So I currently have 55 is equal to each of those added up. Right, so I've got X plus 2. If I expand those brackets, I'd have 2x plus 4 and then 3x. So I have 55 is equal to 7x plus 6. I'm going to subtract 6 from each side, giving me 49 is equal to 7x, and x is equal to 7. Okay, so Amy is equal to 7, Betty is equal to 9, Caroline is equal to 18, and Darlene is equal to 27. So Amy is 7 years old, Betty is 9 years old, Caroline is 18 years old, and Darlene is 27 years old.